Welcome to the Math Record. Today I'll go over the basic method of integration. So basically this is a similar thing of what I covered in our previous video, but I only did one example. So in this video I'm going to do a few more examples so we get a little bit more experience with it. So let's say we want to take the integral of x cubed and we want to take it from 1 to 2, okay, in respect to x. So the integral reverse process of the derivative for our integral would be adding 1 to our exponent, so that's 4. And the derivative of x to the power 4 is 4x cubed. But we don't want 4x cubed, we want x cubed. So that means we need to make that 4 a 1, so we scale by 1/4. And you could add a c if you want, but usually when we have numbers, we don't have to add the c. If there isn't any numbers, we're going to add that c. Okay, so that's just a good rule to know. So we're going to evaluate that integral from 1 to 2. So that's 1/4. 2 to the power 4 is 16, minus 1/4. 1 to the power 4 is 1. So 16 minus 1 is 15 over 4. Okay, let's try another example. Let's say we wanted to take the integral from pi over 2 to pi of sine of x. So knowing our trigs, we know that the derivative of sine is cosine. Well, that's not what we want because that's sine, not cosine. But if we take the derivative of cosine, we get negative sine. But that's not the same thing. So to make this just sine, we need to multiply this by negative. So that'll be negative cosine, which is our integral. Okay, and if you don't know if that is actually your integral, you can always double check. So the negative is a scalar, so we leave that alone. The derivative of cosine is negative sine. Negative times negative is positive, so that's definitely going to be your integral. And we plug in pi over 2 to pi. So negative cosine of pi, which is I'll just plug this in so we show the work, minus negative cosine of pi over 2. Okay, cosine of pi is negative 1. Negative 1 times 1 is 1. Minus cosine of pi over 2 is 0, so that's just minus 0. So that's 1. Okay, so the integral, let's say we do one more example. We do the integral of 1 over x from e to e squared. So this might look like you're going to do the power rule, but it's actually not. In our video for logarithms, we covered natural log of x, and when we took the derivative of that, we got 1 over x. Well, 1 over x is right here, so that means our integral is natural log of x. But the thing is special about our integral is that when we take the integral of 1 over x, it's not simply natural log of x, it's actually the natural log of the absolute value of x. And that's just due to how this equation works specifically with positives and negatives. But just to know, it's going to be an absolute value of x every single time. So whenever you see this form, you're going to use an absolute value inside. But when you take the derivative, you're not going to write that absolute value. So instead, when you write something like this, we take the derivative, we got 1 over x. But if we have 1 over x and we take the integral, is this. Okay, so going back, we evaluate this integral from e to e squared. Natural log of absolute value of e squared. These are already positive, so we don't have to worry about absolute value. So that natural log of e squared is actually 2 times natural log of e. And then we still need to plug in our e, so natural log of absolute value of e. E is already positive, so that's just natural value of e. So natural log of e is 1, so 2 times 1 minus 1 is 1. And that's it. Now let's learn some rules. It's the same thing as similar to derivatives. We take the integral of two things added to each other. It's the same thing as taking the integral of one of them and adding it to the integral of the other. And same thing for subtraction. Take the integral of something minus something else is the same thing as the integral of that first thing minus the integral of the second thing. So this one order matters. So first one, second one, second one. And the last one is a scalar. If we have a scalar c multiplied by our equation, it's the same thing as just taking the scalar multiplied by the integral of that equation. So you could just move that scalar out. And that's basically it. It's the same thing as our derivatives. So let's try an example with this. So let's say we want to find the integral of 2x to the power of 4 plus, let's say, cosine of x this time, with respect to x. Well, let's do 2x to the power of 4 first. That's x to the power of 5. Take the derivative of this. This is 5x to the 4. Well, we don't want 5x4, we want 2x4. So scale this by 2 over 5. So when we take the derivative of sine, we get cosine. So that means our integral is sine. Okay, so that was pretty simple. And as I said earlier, if there's no numbers, we're going to add a c. Okay, and the last thing I want to cover is that not all integrals have a value. So what I mean is, let's say we take the integral from -2 to 2 of 1 over x squared. Well, definitely we could use the power rule here, and then to get an equation, and then we could plug in 2 and -2 to get a number, to get some kind of dx, get some number. But even though there's a number, this integral doesn't exist. And the reason is because if you kind of draw the graph out, how it looks like is something like this. And what you notice is that there's an asymptote at x equals 0, a vertical asymptote. So basically, if you're taking the area from -2 to 2, we have the area of this inside. And as you see, this area, since there's an asymptote, kind of goes unbounded. And that's the reason why there is no integral, because you can't find the area under the curve, because the curve kind of goes up to infinity. And the reason it kind of like gets to this number is that this curve gets so close to this y-axis that the area just kind of shimmers down. And that's the reason why, basically. Or sometimes when you're dealing with graphs that kind of go like this, some negative portions cancel out with the positive one. And that's basically the reason why. And that's good to note too, also, which I did mention. If your curve is above the x-axis and you're taking the area, it's positive. So going back to our example. So if you take the area like here, this is positive, but we take the area here, which is under the x-axis, is negative. So sometimes you could have a value because it cancels out. So if we take the integral like from here to here, it's negative, but it's unbounded. This is positive, it's unbounded, and they come out at like maybe 0. It's even though it has a value, the integral actually does not exist. And a way to check this seems like a lot because you kind of need to know how the graph looks. Well, you kind of don't. And the keyword, as what I said in this explanation, is that we used an asymptote. So basically, you have to check if there's asymptotes here. And the way to do that is check if it's undefined. So if 1x squared equals undefined, so when it says undefined, that's when x is equal to 0, because 1 divided by 0 is 0. 1 divided by 0 is undefined. And we need to check if this point is in our interval. Our interval is -2 to 2, and 0 is definitely in there. Since there's a 0 is in here, there's a vertical asymptote. That means this cannot have an integral. And it's just that simple. Well, thanks for watching, and in the next video, I'll cover integration by substitution.